Okay, so finally we have left the land of linear functions and we are moving into quadratic town, which is, very exciting. As you can see, I'm working with notes that are mine, but you already know that. So this first video is going to be an introduction to quadratics, just real basic, quick and dirty introduction to quadratics, and then a review of linear functions. The next one is the one that you're going to have to take notes on, but I strongly recommend that you watch this one. If you choose not to, it's your business, but I don't know what to say about that. So let's talk about quadratics. Quadratics are the next family. So if we look, there's some vocabulary we're going to talk about, and then we're going to talk really quickly about just about like what you see on the formula chart. So this is a whole nother section of the formula chart. With linear, we were working with like kind of the bottom. It had slope intercept, standard, point slope form, and the slope formula. Well, now we're looking at the quadratic section of the formula chart. We will have this probably in every note packet that we have. So we have two forms of quadratics that we're going to be working with, standard and vertex form. And much like standard form of a linear equation, there's not really much useful that you can get out of it. You can get the y-intercept, which is c, and you can kind of tell some basic stuff about it, but it's not as useful as vertex form. Unfortunately, most of the time we don't use vertex form. We mostly use standard form. So we're going to have to learn how to be able to tell stuff from standard form and vertex form. But really, when you see something in standard form, you're just going to probably want to stick it in the calculator. Vertex form is the form that we're going to be working with primarily in this first in this unit, because it's how we transform. It's the transformation version. And if you recall, we when we were doing quadratics, when we were doing transformations before, we had a, hold on, I'm trying to find a sticky note. Of course, I'm not going to find one now. Why would I? That would be too useful. When we were doing quadratics before, we were doing like transformations. We had f of x equals a times x minus b, right? No, x minus c plus d. Well, you see how similar that looks? A times x minus h plus k. So it's very, very similar to that transformation form vertex form is. So from vertex form, we can find a whole bunch of information about a quadratic. Quadratic formula is about, the quadratic formula is, we're not going to use that until unit 5. And the axis of symmetry we're going to talk about probably in a couple of days. Okay, so brief vocabulary. Let's briefly review linear functions, and then we'll do vocabulary in the next video. Okay, so when we look at a linear function, this is important review because we're going to be comparing linear to quadratic a lot, and so it's important that we know the difference between the two. Okay, so for a linear function, remember, a graph looks like a straight line. The parent function is y equals x. Remember, the parent function is the simplest function that we can write. So it's like plain, not even vanilla ice cream. I think in my class I compared it to ice cream base. Like you can add flavor to it to make it strawberry ice cream, and that might be like putting a slope in here. We can add some like chocolate chip cookie dough chunks to it, which might be like adding a y-intercept. So we can manipulate y equals x by giving it a slope and giving it a y-intercept. And those are some things that we can do to change it. But this is still the simplest, most basic one you can write. In function notation, remember y is the same thing as f of x. So whenever I see f of x, it just means y. So in function notation, I would write f of x equals x. Okay. With our parent function, with our linear parent function, as a reminder, whatever y is, x is the same thing. So whatever I put in for x, I'm going to get that out for y. That makes using points on the on the linear parent function excellent test points, because then I'm never going to get confused about what I plug in for x or y. So if I'm trying to test and see if a point is is a solution on a line, or a solution to a system, or a solution to a linear inequality or system of linear inequalities, I can use a test point, and if I can find something like 0, 0, or 3, 3, or -6, -6, that's going to be a really good test point, because I won't accidentally substitute into the wrong space. When I look at an equation, just the function, just y equals x, linear functions always have all real numbers, and since the domain is all real numbers, if I can put in all real numbers, I can get out all real numbers, where all real numbers means anything. Now, of course, a situation is going to limit that. A situation may, like maybe I'm buying things by the half pound. Well, then I can only have half pound increments. I might be buying pens that cost $3 each. Then I would have, one, I can't buy half a pen. So that means not only would my tens be, my domain would be, you know, whole numbers, positive whole numbers. I would also only be able to use positive whole numbers in multiples of 3 for my range. So my domain determines my range. My domain decides what my range is going to be. When we talked about our parent function, we also talked about, number one, that it's proportional because it goes to the origin. Just pretend that's the origin. Okay. We also talked about how it was, it perfectly bisected. So it perfectly cut in half the quadrants A and quadrants 1 and 3. And again, if this was actually, like if it wasn't squished a little bit, you would be able to see that it actually perfectly cut them in half. And it kind of creates a line of symmetry, which we're going to talk about in the next video. That's about all we had about linear functions. So this is our review of linear functions, and just again, it was a brief review. I wanted you to, you know, have information about it, where you're going to find stuff on the formula chart. The next video is going to talk specifically about how we can tell the difference between a linear and quadratic, and it's going to talk about some vocabulary that we need to know. Will you be quizzed on it? Probably, so I would definitely pay attention, take notes on the next one.